Assalamu alaikum wa rahmatullahi wa barakatuh. This is Ahmed Hijazi from SEG CAD Solutions. Today, inshallah, we will make a tutorial video to create the 3D model for this pressure vessel. It's a horizontal pressure vessel with inside diameter 1 meter point 981 with thickness 10 millimeters for the shell plates. And here we have the dashed head information. It's 2:1 ellipsoidal head with a thickness 10 millimeters and minimum after forming 8 millimeters. Here that's the straight flange value. Okay, let's start proceeding creating this project, and step by step we will know how to generate the 3D model and make all parts to make it make sense. Okay, from here let's click on a new button, and from here let's select a name for this project, and from here that will be the project name. Okay, and let's create it on the desktop. So from here let's click on OK, and let's keep overall module. As you can see, there are different modules here for heat exchangers, storage tanks, spherical tanks, and ducts. So let's keep the overall module and click on finish. By clicking on finish, the project will be created on the desktop. Here we have this project, and here's the project information. From here we could define the job number of this project. So let's come back here, define the job number. You can define the other fields here for the project name, plant name, client, and owner. Now let's click on save, and let's come here on the vessel node, and let's give a name for this vessel. So that's the vessel name. So from here let's right click on the vessel and rename the vessel and click on OK. Now from the vessel setting, let's open the equipment setting. From here you can define the service of this vessel, the serial number. So from here let's take the vessel name, train collection vessel, and the serial number. And from here, if you take a look, you can change the position of the vessel from horizontal, tilted, and vertical vessel. In our case, it's a horizontal vessel. But if we take a look on the drawing in deep, you can figure that the reference line laid on the right hand side. So in this case, we need to define the location of the nozzles from the right hand side. So here in SEG, we will change the direction of the assembly to make it start from right to left. Okay, so here we will make it horizontal vessel and change the position or the direction of the assembly from right to left. And let's click on save. Now let's create the first item, which is this ellipsoidal head. Okay, this ellipsoidal head with inside diameter 1 meter point 981. So from here let's select head and name it as a right head. Click enter. Now here you will find a list of different type of heads, available heads in SEG, more than 17 types. The first type is the ellipsoidal head as a half of ellipse. If you take a look to the image on the right hand side, it's a half of ellipse. No crown radius or knuckle radius exists. But if we select the second type here, which is a head with crown and knuckle radius, ellipsoidal head with crown and knuckle radius, easily it's related to the ASME code. So you can figure that the crown radius equals 0.9 and from the inside diameter, and the knuckle radius equals 0.17 from the inside diameter. Okay, so from here let's define the inside diameter of the vessel, which is 1 meter 981, and the thickness is 10 millimeters. The straight flange is 50 millimeters. Minimum after forming is 8 millimeters. And here the material of this head, it's SEG 516 grade 70 NACE and HIC. So we get it from here from this drawing. If we take a look to the material specification, you can figure that the shell and head material it will be NACE and HIC. So from here, let's change the material of this part and click on save. Now, if we click on start assembly to generate this item or this part on Autodesk Inventor, you can figure that easily the let's wait a second. The direction of the head is not suits the same direction of the head in the drawing. The convex direction is flipped, so we need to flip the direction of the head from here by clicking on this button to flip the direction of the head. Now let's add the second element, which is CAN1. Okay, here we have the first can. If we take a look to the first can here, it's 1 meter point 99880. So from here, let's select CAN1 and select the suitable type. In this case, we have single welding line. So let's select shell type and define the inside diameter of the shell, the thickness and longitudinal welding line orientation, and the length as per this drawing, which is 1880. The welding gap, let's make it 1 millimeter. Define the material and click on save. Let's add another can. So from here, let's add can2. And let's make it looks like can1, but we will change the longitudinal welding line orientation and the length of this part. So from here, let's change the longitudinal welding line orientation and the length of this part to suit the drawing requirements. Here, that's the length of the second part. And regarding the orientation, that's the orientation or the longitudinal welding line orientation. Okay, let's add the third can. So from here, let's add can3. And let's make it looks like can1. It's actually the same information for can1, the same length, the same longitudinal welding line orientation and thickness. Now let's add the last main part, which is an ellipsoidal head, which is left head. And let's make it looks like the right head, the same dimensions of the right head, and click on accept. But as mentioned on the first head, it's the convex direction is not, we flipped it, but in this case we will not need to flip it. So let's remove this checkbox and click save. Now let's create the 3D model for all of the vessel. So here, that's the first head. As you can see, the assembly starts from the right side to the left hand side. The third can, after that the last can. Okay, now we have the main parts of this vessel. Now we will proceed with creating the attachments like saddles, lifting lugs, nozzles, all of that called childs or attachments to the main elements. Now let's come back to the drawing. Here we have two support saddles with stiffening rings. Okay, and if we check the saddle drawing here, okay, so let's take the dimensions from the saddle. So let's come back to SEG and select the first can. Okay, and from elements, when you select a main part, you will find here on the element list the available attachments that you can add it from SEG library. For example, here for the supports group, you can add saddle, tilted saddle for the tilted vessels, stacked saddles, legs, lugs, skirt, anchor chair, different type of cradle. For the nozzles, you can add a nozzle with external projection, nozzle with external and internal projection, API nozzles, couplings, clean outdoors, weld outlets, stud outlet, coupling. For the lifting devices or lifting lugs, you will find different types of lifting lugs and trunnions. For the external attachments, you will find a huge list of elements to add inside or outside. Okay, so let's select the can, and from here let's add support saddle. So the first saddle will be the fixed saddle. Okay, and from here let's select the suitable type for the saddle. You will find here 12 types of saddle. In our case here, if we take a look to the saddle drawing here, you can figure that the whip position on the right hand side. So from here we will select the saddle, and the whip case will be to the right. Now let's define the saddle contact angle. It's 120. The height is 1350. The width thickness is 13 millimeters. And we have a wear plate, the wear plate contact angle, and the width of the wear plate, the thickness of the wear plate, the fillet, the material of the wear plate, and the base plate length, the base plate width, and the thickness. The hole diameter is 30 millimeters. The hole offset from the short edge is 243.6, and from the long edge 1 to 7. So let's take a look to the drawing here. The hole on the middle of this distance. So we will divide this distance by 2. So the offset of this hole from the long edge, that's the long edge, it's a half value of that one, and the offset from the long edge, the short edge, sorry, that value. Those are the values here. Okay, now let's add the number of holes. We have 4 holes in the base plate material here. Here the location of this saddle and the orientation. So here SEG give you the ability to control the orientation of the saddle if you have hanging vessel and the saddle at the top, or hanging vessel and the saddle on the wall. So you can change the orientation of the vessel by changing this value. Here the wear plate offset is 26, and from here we haven't a cut on the whip, and the offset of if you take a look to the parameter here, which is a base plate offset from the back of the whip, so it's 13 millimeters based on this drawing. If we take a look here, we have 13 millimeters here, and between that and that one we have 26 millimeters from the whip and the wear plate, which is that value 26. Okay, now let's define the top rib width, which is in our case, if we take a look here, it's 2 to 8. So here 2 to 8, and at the bottom 228. The thickness is 13 millimeters, and the chamfer, let's keep it 20 millimeters. We have an intermediate ribs. Okay, we have an intermediate ribs. If we take a look to the image here, we have an intermediate ribs and a mid rib. So we need to activate the mid rib and one of the intermediate ribs. So from here, let's activate the mid rib and an intermediate ribs here, and define the spacing between them. Okay, so that's the spacing between saddles. Let's click on save and start the assembly. Here you can figure that SEG creating the 3D model of the saddle on behind. So if you would like to make a preview for the elements during creation, make a rendering for the elements during creation, there is an option. We will activate it after creating the first saddle. Okay. Here Okay, this option we can activate it, but we should still this button become blue again to finish the assembly. Okay, so from here let's open the app setting, and from here let's select child preview and parent preview. Let's take a look to the model. Now the saddle is created. Okay, so we have the 3D model of this saddle. Okay, now we can save the setting. When we click on save and come back to SEG to create the second saddle. So from here, let's add another saddle on CAN 3. We could add it on CAN 1 and define the elevation of it from the start of CAN 1. But let's add it on CAN 3. So it's a sliding saddle. Okay, and click on save. So for the sliding saddle, if we select it, in this sliding saddle, you can figure that the web on the left side. So let's select the left side web and define the dimensions of this saddle. Here define the rear plate, the contact angle, rear plate width, the thickness, the fillet weld, and the material of the rear plate. Define the base plate length, base plate width, thickness, and hole diameter, the offset from the short hole, and the offset from the long side. Here we have a slot hole, so let's define the slot length. So let's select this checkbox, which is sliding support. Define the slot length. Define the number of holes as one hole. I will let you know why I make it one hole, and on the first saddle we make it 4 holes. I will show you the difference between the dimensions. Okay, here let's define the location of this saddle. So this saddle reference is the third welding line here. So the reference here, that welding line. So the location of the saddle will be laid from this welding line because it's now located. It's located now on CAN 3, so the reference line will be measured from here. So that's the value from the welding line, and define the other dimensions, 13, and outer rib. So the width of the web will be like that. The thickness will be 13, and we have a mid rib. We have an intermediate ribs, 8, 6, 2.2. And now let's click on save. Now let's start creating the 3D model for the second saddle. And here you will figure out the difference before selecting the option of parent preview and child preview. Here you can figure that the saddle child created and Autodesk Inventor make a rendering for it during creation. In the first case, everything created on behind and assembled to the final model in one time. But here you can figure element by element during creation. Here that's the outer ribs, the mid rib, and after that the intermediate ribs. Here the intermediate ribs. At last we will get the rear plate. Okay, here we have all elements of the saddle. And the next step, I will show you the difference between the option of 4 holes that we created here and the option of 1 hole here on this saddle. Okay, let's open this saddle and create a quick drawing to check some dimensions. So from here, let's open a quick drawing and let's add a view. here, make it 1, 2. Okay, and let's take a section to figure out the holes locations. If we make a center line here, there, and measure the distances between here and there, it's the same distance which defined it here on the saddle, which 243.5. Let's come back here, 243.5 or 0.6. Sorry. Okay, we could change it to 0.5, no problem. Okay, but here, if you measure the distance between the holes, you can figure that they are equal. Here, SEG creates them with equal spacing. Okay, but in actual, on the original drawings, the spacing is not equal. Here, if you take a look to that value, okay, and the double of that value, so if we multiply or make a summation for those, you can figure that that value is not equal to that value. So how we can make that by using the Autodesk Inventor options. Here, if we come back to the 3D model for the second saddle, let's open this saddle, okay, and open the base plate here. By that, we can make a pattern for this slot hole, sorry, let's select this slot hole and make a pattern with that distance, okay, which is 440.8. Okay, 440.8, reverse the direction, and you can make a mirror for that on the mid plane, and let's click save. When we open the drawing here, let's move this little bit outside the drawing here, and let's add the second saddle detail, and let's take another section here. That's for the sliding saddle, and let's add those center lines here and there. Okay, and let's measure the distance. Here, that's the distance from the edge, and that's the spacing here, and you can figure that the spacing now become not equal. So if you would like to make them with equal spacing, you can directly select the option of equal number of spacing here by adding the number of holes here, which is 4 holes on the fixed saddle. But if you would like to make them with unequal spacing, you can do it by making a pattern from Autodesk Inventor. Now let's add another stiffening rings to those saddles. So from here, let's select the CAN one, and from here, let's open the external attachments and select external stiffening. And let's add stiffening ring 1. Here, that's the first stiffening ring. Okay, let's come down here and select built up section and define the height of this section, the thickness. So we have a detail here for that one. So if we take a look here, that's the height of that whip, and that's the top plate width and thickness here. Okay, so let's come back to SEG and complete defining the data, and the location will be the same saddle location, and we have a top plate, the top plate width, top plate thickness, and here the longitudinal building line orientation, and the gap, here the material, and click on accept. Let's add another stiffening ring on the other can. So sorry, let's add a stiffening ring. So stiffening ring 2, and let's make it looks like stiffening ring 1. So if you select it like that and click save, if you move to another point and come back to the stiffening ring, you will find the same information here. Just we will change the location to make it looks like the second saddle, and click on save. Now you click on start. We will start generating the stiffening ring. Here the first part, which is the whip. After that, the top ring. Okay. The second stiffening ring. Okay. Now we have two stiffening rings over the saddles, and you can figure that there is an intersect between the stiffening ring and saddle, and on the end of this video we will make the modification to make the stiffening ring suits the cut on the saddle. Okay, so keep watching this video to learn how to make a cut on the stiffening ring to suit the saddle configuration. Now let's add an earthing lug or a ground lug and add it to the support saddles. So from here you can, as discussed, you can add attachments to the main elements only. It's not an option to add a child to another child. So how we can add a grounding lug to a saddle? So if you select the saddle, the shell from here, and from the external attachment, you can find an option here to add a grounding lug to the shell. So let's add it to the shell. Ground lug 1. We have a grounding lug here. So this grounding lug, you will select the suitable configuration for this one. So from here, let's define the width, which is dimension A, which is 65, and the height is 125. The thickness is 6 millimeters. It's without a chamfer, and the location, any location and any orientation right now. The whole diameter is 15 millimeters, and the offset is 25 millimeters. Now let's create this grounding lug. Okay, here we have this grounding lug on the shell. Now it's assembled on the shell. Now we need to move it to the saddle. Okay, so we will learn how to remove the constraints from here and move it to the saddle. One more point here, if we take a look to the this detailed drawing for the grounding lug here. Sorry, for this grounding lug, you can figure that we have a fillet here. And the option in SEG is a chamfer, not a fillet. So how we can make a fillet here on this grounding lug? If we open it, let's open this part here. By selecting the fillet option, you can make a fillet here and define the fillet value. So if we make it 25, for example, so you have a fillet here on this grounding lug. So now the second step to move this grounding lug to the saddle. So from here, let's select the grounding lug, and you can figure that you have 3 default constraints with the planes here. If you take a look here, you have a constraints here, and those are, so we will delete them to make this grounding lug free. Now we can make a constraint for this grounding lug. So let's make this surface mate to this surface, and to check the dimensions, let's open the location of this one. So from the mid plane, and here the location, it's from the facing to the center 152. So if we come back here. We have a plane at the middle, so let's select the mid plane here. So from here, the mid plane to here, 156 millimeters. Okay, and click on accept. And from here to there, let's define it to be like that. Now we have this grounding lug on the saddle, and it's still defined on SEG. So if you open the bill of material, you will find this grounding lug defined it here with the material and all dimensions of this part. Okay, now let's add a lifting lugs to this model. So if we open the 3D model, you will find lifting lugs here and there, and on the side view, those are with on angle 35 degrees. So from here, let's select CAN 1, and from elements, let's select a lifting lug. So you can figure that you have different types, but for the required type, it's lug 2. So from here, let's add lug 1. And from lug 1, let's define the dimensions of this lifting lug. The offset, which is dimension D, it's 100 millimeter, and the offset E is the half of the width. The thickness is 20 millimeters, 10, and the radius is 75. The whole diameter is 50 millimeters. And from here, let's add a wear plate. So dimension A will be 200 millimeters. The width is 420. The thickness 10 millimeters. The width will be the fillet will be 25, and the material will be a normalized material. And the location for the first lifting lug will be at that position, and the orientation will be on 35 degrees. Now let's click on save and create this lifting lug to check the location of this one, the orientation, all of that. Here, as mentioned, a preview for element during creation takes place here. That's the lifting lug assembly. Okay, let's add another lifting lug on the other side. So let's add lug 2. Lug 2. It looks like lug 1, but on another orientation. So the only thing we will change is the orientation. So the orientation will be 3 to 5, and click on save. Let's add another 2 lifting lugs, which is lug 3. Lug 3, it looks like lug 1, but with a different location. So the location of this one will be 5046. Click save. Another lifting lug. Lug 4. It looks like lug 3, but with a different orientation, on the same location but with different orientation. Change the orientation of this one, and let's click start the assembly. The third lifting lug, and the last lifting lug, which is lug number 4. Okay, here we have the assembly for the vessel with saddles, stiffening rings, and lifting lugs. Now let's proceed with creating the nozzles as per this drawing. So let's start from the first can. We have two nozzles on the first can. We have manhole and another nozzle, which is N3. So let's create the first nozzle, which is manhole. Let's select can 1 because this nozzle is located on can 1. Okay, so let's select can 1, and from elements, let's add a nozzle. And this nozzle with external projection only, no internal projection. If we take a look to the image here, or to the drawing here, no internal projection for this nozzle, but here for those nozzles, for example, we have an internal projection. So during selection, we will select shell nozzle for the with external projection for this one. So here it's the manhole, and from here, this manhole size is 24 inches, but it's from blade, not from pipe. We have a welding line here on the neck of this nozzle. So to select the suitable type here, you will find more than 25 different types of nozzles. So the suitable type for this case here, it's a nozzle from blade connected to shell. So let's define the outside diameter of the nozzle, which is 24 inches. So from here, the thickness 10 millimeters, the longitudinal welding line orientation, the weld gap, and the location of this nozzle, the orientation at 0 degree, and the blade material of the neck. It will be the same shell and head material. So let's define it to be like that. Let's add a reinforced pad with 100 millimeters width and thickness. Here the material is normalized, and manhole. That's the description of the service of this nozzle. Let's click on save. To define the projection, let's add the flange first. After that, we will define the projection to the facing of the flange. So it's manhole face flange. Sorry. From here, let's select the flange, and from the list here, let's select the suitable flange. Those are standard flanges, and in our case, we have a weld neck raised face flange according to ASME P16.5 with 150 rating. The size is 24, and the thickness is standard, not a standard thickness, it's 10 millimeters. That's the end thickness of the flange, which equals the thickness of the neck. Now let's select the material of the flange, okay, and paste it here, and click on save. Now if we come back to the manhole again and open the calculator form and define the projection of the manhole, if we take a look to this view, you can figure that the projection of the manhole here, it's 1500 to the facing of the flange. So let's come back to this view again and define the projection 1500 and click calculate. So that's the projection of the pipe. The projection of the pipe calculate here on this form. When you click save, it will be reflected here to this text box. So if you click save, you will find this value reflected here. Now one more thing we will do, which is the weld setting. From here, if you open the weld setting of this nozzle, you have the ability to define the weld style, if it's a single V or double V, and without clad or with a clad to the parent or clad to the parent and the child. In our case, it's a single V and no clad. Let's define the fillet weld here and there. It's 8 millimeters on both sides, and click on save. Now, if you open the nozzle table, from the tables, if you open the nozzle table, you can figure that you have nozzle edge. The surface of this nozzle is a manhole, the outside diameter, thickness, and flange class, flange type, and flange facing. Here the projection from the vessel center line, and the bad thickness, the bad width, and the weld style, and the values of the fillet width. Now let's add manhole and a gasket to this one, because this manhole has a gasket and cover. So let's select the external connection here, and from elements let's add a gasket. So MH gasket and define the gasket type. Select the suitable type, which is according to ASME. Select the same rating, the size 24, and click on save. Now let's add a cover. So from external connection, let's add a blind. So MH cover. And from here, let's select the cover node and select the required type, which is raised face blind flange. Select the size and define the material, which is the same material for the forged. So let's click on save, click on paste. And from here, let's click on flip to flip the direction of the facing of this blind to be on the direction of the gasket, and click on save. Now, if you click start, you will get the nozzle. Here, that's the nozzle neck with a welding line. Here, as you can figure, you have a welding line here on the nozzle. That's the welding line. And the flange. After that, the gasket. Okay, now we have the blind flange connected to the nozzle. Let's proceed with the second nozzle, which is the bottom nozzle here, which is nozzle N3. We will add the other attachments like the davit, the hand grip, all of that at the end, inshallah. Here we have nozzle N3. If we come back to the nozzle table here, to check nozzle N3, nozzle N3 is 4 inches with a rating 300 and schedule 120. So let's add nozzle N3. So from elements, let's add N3. Click save. Now from here, it's a nozzle from pipe. So let's define the size 4 inches, schedule 120, and the location for this nozzle is 450. The orientation on 190 degrees, and the pipe material. So let's select the pipe material from here and click paste, and the service drain. Okay, we have a reinforced pad with 58 millimeters width and with a normalized material. And let's click on save. We will change the projection from the calculator after adding the flange. So from the external connection, let's add in 3 flange. And from here, let's select weld neck raised face. Select the rating, it's 300 and it's 4 inches, schedule 120, and the material, the forged material here with NACE and HIC. So find it like that and click on save. Now when we come back again to nozzle N3 and open the calculator, you can define the projection of this nozzle. If we take a look here, the projection will be 1250. So let's define the projection here, 1250, and click on calculate the projection. Here, that's the value of the projection. If you click save, it will be reflected here. Now let's open the set weld, define the weld size, and click on start the simply to create the next nozzle, which is nozzle N3. That's the nozzle neck, and here's the nozzle rebad. After that, the flange for this nozzle. Okay, now let's add another nozzle, but in that time we will add the nozzles on the second can. Those nozzles, which is N7, 9, 2, 5, 1, and those helicide nozzles, which is N8A and N8B. So let's start with N7. If we come back to the drawing here, if we that one N7 here, that one. Okay, So N7, it's a long-welled neck nozzle with 2 inches nozzle with a rating 150. Okay, so let's open here and select the can 2. So you should select the can 2, and from elements, let's add a nozzle, which is nozzle N7, and click add. And from here, let's select the suitable type, which is long-welled neck connected to shell. And from here, select the rating, size, and the location of this nozzle, 170. The orientation, it's the same. And here, that's the material for the forged. Define the material here. And let's keep this value as it is. Here for the calculator, let's calculate the projection, 1500. Click calculate. So that's the external projection. The value will be reflected here. After that, we will take this value as a copy, because we will use it for the this nozzle rib, because we have a rib for this nozzle. We have stiffening ribs for this nozzle. If we take a look on this detail for this nozzle N7, here we have 2 ribs, 2 perpendicular ribs here. So we will need this value for the nozzle location. So from here, let's open the assembly, and from external elements, let's add a nozzle support rib. So N7 ribs, and from here, let's select the first type of nozzle ribs. Define the outside diameter of the pipe. You can measure it from the drawing if you create it. It's for the 2 inches long weld neck nozzle. It's 78. And for the rib width is 40 millimeter. The rib thickness and the rib angle. The location of this nozzle, the same location of the nozzle. The orientation at 0 degree. The material is normalized. The offset, if you take a look to this drawing, the offset from the facing of the nozzle is 70 millimeters. So let's define this as 70 millimeter. And here, that's the projection of the pipe, which is the value that we copy it from the previous 4. Okay, and let's add another stiffening rib. If you take a look to the image on the right hand side, here that's the rib. Okay, and here rib number 4 and rib number 3. We need to make a rib on that side. So we need to make a rib on that side. So we will select rib number 4 and define the angle. Let's make it 20 millimeters. And from here, let's define the offset to be 70 millimeters. Define the material, and let's click on save. Now let's click start assembly to create the nozzle N7. That's the first stiffening rib. The second stiffening rib. Okay, so you can figure that you have 2 stiffening ribs here. As you can see, the longitudinal welding line orientation is near to the this stiffening rib. And if we take a look to the drawing here, you can figure that it's 20 millimeters for the lateral one, but for the second one is not mentioned. Okay, on the longitudinal direction is not mentioned here on this view, and already we have one view only, so it's not mentioned on the second view. So we can change it. So we can increase this angle only for that rib only, because you can control each angle for each rib. So for here, we will increase the angle for the third rib, second rib, and click save. Now if you click start assembly, we will change the angle of that rib, so you can figure that we have a clearance here between the welding line and this rib. So here you have 20 degrees for this one, but for that one we have 30 degrees. Okay, if we come back to the drawing here, we have a gasket and blind flange here. So let's add a gasket for N7. So from here, let's add N7 gasket. defined the type of this gasket, keep the rating and click on save, add a blind flange, so N7 cover, and this cover will be ASME P16.5 with a raised face, 2 inches, and make it flipped. And from here, let's take the material of the forged, paste it here, and click on save. Now let's add another nozzle, which is nozzle N9. If we come back to the drawing, we have nozzle N9. It's a weld neck nozzle, and let's check the dimensions of this nozzle. Here it's 3 inches, 150 rating, and the scalable 160. Okay, so let's create this nozzle. So from here, let's add N9. Okay, N9, it's a nozzle from pipe, the neck is created from pipe. So the size is 3 inches, schedule 160. Let's take a quick look. Yes, 160. We have a reinforced bed, and the width of this reinforced bed is 55. The material is normalized material, and the location of this one from the shell is 566. And for the material, it's a pipe material. Okay, so let's define it here, and let's click on save. Let's add a flange to calculate the projection. So N9 flange. Okay, that's it. Select the rating, size, and schedule, and define the material of the forged here, and click on flipped. Sorry, it's the flange, sorry. So it's for N9, and click on save. Now when we come back to N9 to calculate the projection, 1500, calculate, click save. Now the weld style 8. Now let's create this nozzle. That's the gasket for nozzle N7. Okay, if we come back here, okay, we make a mistake here because this nozzle was internal projection, okay, not with external projection only. So if we take a section here, let's take half section, you can figure that this nozzle without internal projection. Okay, so let's keep it like that, and change the second the next nozzle, which is N2. Okay, here we take a look here, N2 with internal projection. Let's create it with internal projection, and let's show you how you can create a nozzle with internal projection and how you can add the attachments. So let's select N2, and from here, instead of that type, we will select that type, which is nozzle with internal projection and external projection. So from here, let's add the next nozzle, which is N2. Okay, and N2, the same properties, it's 3 inches, 160. And for the location of this one, the orientation, it's the same. And for the material of the pipe, that's the material of the pipe. The wear plate, it's 55. Normalize the material for the reband. And here the surface, let's click on save. And for external, let's add a flange. So N2 flange. Define this flange. We will make it looks like N9. So from here, select it directly. And if we come back to nozzle N2, when you open the calculator, let's define the projection. Click on calculate, click save, define the weld. Here you can figure that you have 3 values for the fillet at the inside, fillet between the rebad and the shell, and the fillet between rebad and nozzle. And the C, which is between the nozzle and shell from inside. Click Save. Now let's start the assembly. To create the 3D model of this nozzle, which is nozzle with internal and external projection. Okay, now let's add some connections to this nozzle from the inside. We have 2 weld neck flanges with a deep pipe. So from here, let's select, you can figure that this nozzle include internal and external nodes. So from internal, you can add some attachments. So from here, let's first change the internal projection of this nozzle. And from internals, let's select the elements, and from here let's select flange into F1, and during the selection of N2 we can change the type of this nozzle, select the rating and the size of this nozzle, schedule, and define the material as forged material, and click on save. Now let's add a gasket. So from here, N2 gasket. Okay, select from here, find the material and click on save. Now let's define the add a blind flange. Add another flange. We have another connected flange. So N2 F2, and let's make it looks like N2 F1 because it's on the same level. So if you click add, you will get it here, but we will make it flipped to flip the direction of this flange. After that, we will add another pipe after this one. So N2 pipe. From here, let's select the pipe, select size and schedule, and the length of this pipe we can add it as like that, and change the pipe material. Sorry, from here and click on. Sorry, that's the pipe material, the length, and here's the pipe material, and click on save. Now if you click on assembly, you will get the connected flanges. The internal projection will be modified. That's the first step. After that, you will add a flange to the end of the nozzle. I think I select 4 inches instead of 3 inches. So may I need to change the size, because this nozzle is 3 inches and but the flange is 4 inches. So if we check that, we come back here. So let's change that value to 3. The same for the gasket. Here it's for the second flange, it's 3 inches. Click on save, and for the pipe it's 3 inches. Now let's click start to update the flange's size. Okay, so by that way you can modify or create a nozzle with internal projection and add connected elements to the internal connection of this nozzle. By the same way, we could make nozzle in 9. Okay, so let's go to the next nozzle, which is in 5. So from here, let's select CAN 2, and from elements, let's add N5. It's 6 inches. Okay, with schedule 80. Sorry, 80. And the location of this nozzle 1466. The orientation is at 0 degree. the rebad is 85 width, the material is normalized, and the pipe material here, the pipe material. Let's click on save. Let's add a flange here in 5 flange. Okay, so let's select the type. So the rating for this one is 300 and the size is 6 inches, schedule 80, and the material will be 350 LF2 class 1, and let's click save. Let's add another nozzle. Okay, let's modify the projection before going to the next step. So the projection 1500, click save, and the build style, let's define it to be like that. Let's add another nozzle, which is N1. So here we have nozzle N1. So let's come back to SEG, and from here let's add N1 and select this node. It's a nozzle from pipe with 4 inches schedule, 4 inches size, 120 schedule. The location of this one 2070, and with a rebad 60 millimeters as a normalized material. And for the pipe material, it will be like that. Let's click on save, and let's add N1 flange. So N1 flange, define the type of the flange, define the rating, the size and the schedule, define the material. Okay, and click on save. Now we have those two nozzles. We will remove the setting of preview for the child and the parent and click on save. Okay, and make assembly directly on the final assembly. So that's nozzle N5 with the flange. After that, nozzle N1 with a flange, but we forget to define the projection for this one. So let's come back to N1 and open the calculator and define the projection and the weld style or weld size. Now let's add nozzle, two other nozzles, nozzle N8A and B. Those are helicide nozzles. Okay, and for the detail of those nozzles, here we have those nozzles. Okay, so let's start with N18. So here let's select elements and N8A, sorry, N8A, click add. Okay, it's 4 inches nozzle with a schedule 120. The location of sorry, it's 2 inches, sorry, a weld neck nozzle with 2 inches. So let's select long weld neck connected to shell with a rating 300 and the size is 2 inches. The location of this nozzle is 170. The orientation will be on 90 degree, and the material of this one will be a forged material. Okay, and the projection we will calculate it, but it's not a radial nozzle, it's a helicide nozzle. So let's select this checkbox, and automatically you can figure that you will get two values here. Here, that's the first value, which is offset, and the offset direction. So from here, let's define the offset. The offset of this nozzle is 600 millimeters. Okay, so from here, let's select 600, and the offset direction on the counterclockwise, because we defined the orientation of this nozzle on 90 degree. Okay, so the offset will be on the counterclockwise. So let's select it from here like that and click on save. Now from the calculator, let's calculate the projection. So if we come back here to this view, it's 1200 the projection of this nozzle. So it's 1200. Click calculate. Now that's the projection of the long weld neck nozzle. Okay, so it's reflected directly here. Now let's define the fillet weld and click save. Now let's add a support for this nozzle. So from here, let's select a nozzle support. It's N8A ribs. Click on save. And from here, let's select the first type, define the outside diameter of the forged hub. It's the same for the long weld neck here, because they are 2 inches. As we discussed, you can measure it here, or directly if you have the value, you can add it here. The rib width and the rib thickness is 10 millimeters. The rib angle, let's make it 30. And the location, the same location of the nozzle. The orientation is 90 degree, and the material is a normalized material. The rib offset is 70 millimeters as per this drawing, the offset. Okay, so we define this offset, and the projection should be the projection of the nozzle. So let's save it and come back to the nozzle. Take a copy from the projection here, take a copy and come back to the rib to paste this value. Okay, and it's not a radial, it's a helicide, so we will define this value with the same information of the nozzle. It's a counterclockwise, and we have another rib here with 30 degrees and 70 millimeters offset. And now let's click on save. Now let's start the assembly. We will need to remove this section, make a complete cut. At the beginning, we will need to create the first nozzle, which is in 8. After that, the stiffening ribs. Okay, so that's the first strip. Okay, so from here, if you if you take a look to the image here, to the drawing here, so this view, we have a rib on that side and another rib to that side. Okay, if we open, you can figure that we get one only. Maybe the sketch, the dimensions is not correct, so let's open this one. So the assembly is including 2 stiffening ribs. Okay, we have, that's the first stiffening rib. Okay, so if we go inside and check the sketch, okay, we have an error inside the sketch. So let's make a quick modification, okay, to here. So from here, let's make the rib angle with that value, and the other rib will be on the other side, not that one, because as per this drawing, the rib on that side, not that side. So let's activate rib 3 and click on save. Now let's click run the assembly. Here the first rib appears, so the sketch needs some modification. So now I think we can change the value. It's with 10 inches degree, so we can change that value now to 30 degrees. Okay, and let's add another nozzle, which is N8B. N8B. And from here, we will make it looks like N8A. Okay, but it's on another orientation. It's a counterclockwise, not it's a clockwise, not counterclockwise. So let's refresh the node by moving to another node and come back here. The only thing we will do, which is make it clockwise. Okay, and click on save. Now when you click on start assembly, the first thing, this rib contact angle will be changed. After that, the second nozzle, which is N8B, will be created. Now let's add another rib for N8B. So from here, let's select CAN 2. Okay, and from here, let's select stiffening rib N8B ribs. Okay, and from here let's make it looks like in 8 ribs, and let's make a refresh for the node and come back again to load this node information. And from here let's select the other side, because as you can figure, the main rib will be on that side. The main rib will be on that side, not at below here. It's at top. So let's select other side, and from here we will keep rib 3 as it is, and we will make this angle as 10 degrees and create the 3D model. For the ribs. Okay, let's change this one to 30 degrees. Click start. Sorry, we need to change it to make it on a clockwise. Sorry, we need to change it on a clockwise, because as you can figure, it's laid on the this nozzle. So let's make it on clockwise and click on save. Now when you click start simply, we should make the same information of this nozzle looks like the parent nozzle. Okay, so here we have this stiffening rib for this nozzle, like that. Okay. Now, if we measure this value, as I can see, we have, I think, we need to increase the outside diameter of this nozzle, because the rating of this flanges differ. So it's 8.4. Okay, so we need to change this by body to 8.4 here on this rib and that rib. Okay, 8.4 like that, and click start. Okay, after creating, updating those ribs, we will proceed with the last course nozzles. We have 3 nozzles here and another nozzle there. Okay, so let's come back here and select can 3, and from elements let's select N6 nozzle. It's a nozzle from pipe with 6 inches with the schedule 80, and at the location 4,430, the orientation at 0 degree, the material of the pipe, and here the width of the rebad, the material of the rebad, and let's add a flange for this one. So from here let's add flanges, N6 flange. Okay, let's check here, which is N6, it's 150 the rating. So from here select the type, size, and schedule, and here's the material of the forged flange. Click save. Okay, and from here if we open the calculator to define the projection, 1500, and for the set weld 8 and 8. Okay, this nozzle without blind, let's go to the next nozzle, which is nozzle N10. So let's select this one. So N10. It looks like N6. So from here, let's make it looks like N6, and let's add a flange to this one, which is N10 flange. Okay, it looks like N6 flange, but we will come back to N10 to change the location of this nozzle. So as you can figure, you have a different location for this nozzle, so we need to change that one. Okay, keep the information as it is. If we take a look to the N10 here, yes, it's the same rating, the same schedule, the same size, so everything is okay. So click on save. Now let's add the next nozzle, which is in 11. Okay, this nozzle, it's a long weld neck nozzle. So let's take a look to the table here. 2 inches, long weld neck, and 300 as a rating. So from here, let's select the shell, can 3, and from here, let's select in, we already created here, it's in 11. So let's select long weld neck nozzle, the rating, the size, and from here select the location, define the location, the orientation, the material of, the material for forged material, and click on save, and from the calculator define the projection. Okay, so the value will be changed here, and the fillet weld. Now let's add a stiffening grip for nozzle in 11. So from here, let's add stiffening grip in 11 grips. Okay, so from here, the outside diameter, the width, thickness, contact angle, it's 20, and the location, the same location of nozzle in 11, the orientation, the material is a normalized material, rib offset 70 millimeters, the same projection of the nozzle. So let's come back to nozzle in 11 and take a copy from the projection and come back here, paste this value, and let's add a stiffening grip here, stiffening grip number 3, and the rib angle 30 millimeters and the offset 70 millimeters. Click save. Now let's generate N6 nozzle with the flange. After that, N10. Now nozzle in 11, and the ribs of this nozzle, stiffening ribs for this nozzle. Okay, here we have stiffening ribs for this nozzle. Now we have one more nozzle at the bottom, which is in 4. So let's select can 3, and from elements let's add N4. Okay, nozzle N4 is a nozzle from pipe with 6 inches diameter with the schedule 80, and the location of this nozzle 1430. The orientation at the bottom, so it's 180 degrees, and the material of this one is the pipe material with 85. Normalize the material for this one, click save. Okay, and for the projection, as mentioned before, we need to import the flange to calculate the correct projection for the nozzle from the facing of the flange. So select this one, select the suitable type, select the rating. So let's check the rating first. It's for nozzle N4. So nozzle N4 with a rating 300. So let's select 300, select the size, and the schedule is 80, and the material of the forged. So from here, let's paste the material and click save. Now if we come back to nozzle N4, in that case we can define the projection in a correct way. So it's automatically reflected here. Define the fit weld, and now let's click on simply. Okay, but the projection, I think at the bottom it's different. It's not 1500, it's 1000 and 250. Okay, so we will come back to the projection here and change it to be like that. Click Save, and now click Run to update the projection of the bottom nozzle. Okay, one more thing here. If we come back to the drawing, we have those nozzles with blind and cover, which is nozzle N10 and N11. So here that's N10, so let's select the external connection and add a gasket. So N10 gasket. Okay, select the suitable type of gasket, select the rating. So let's check the okay, it's 150. So the size of nozzle N10 is 6 inches, and click on Save. Now let's add a cover. So from here, let's add in cover. So the cover, select the raised face type, the size, and flip it. And from here, let's select the material, copy the material here. Okay, and for nozzle 11 and 11, let's add a gasket in 11 gasket. I think it's a 300 and size is 2 inches. Let's add a cover in 11 cover. Okay, so from that one, we will select the raised face, select rating, size, and the material, and make this flanges flipped. Now let's click on Start Assembly to start creating the body flange and the gasket for nozzles N10 and N11. Okay, sorry, it should be 2 inches. So let's come back here, select 2 inches instead of 3. Click Save. Now let's start the assembly to update the body flange, the cover flange. Sorry. Here we have the 3D model of the equipment. Just we need to make some more modifications for the ring cut here. The cut on the ring. Add a vortex breaker there. Okay, and adding stud bolts and davit. Okay, so, and some internals here on this nozzle. Okay, let's start with adding a vortex breaker, or before vortex breaker, let's do a cut for nozzles. Here, if you take a section on the visit at the half here, you can figure that no cut for on the shell. Here you have a complete shell, no cut for nozzles. So if you would like to make a cut for nozzles here, let's make it by using a tool in SEG software. So before proceeding with that, you can figure that we make the complete 3D model for this equipment in, I think, 1 hour, maybe less than 1 hour. And we will make some customization here. Let's load the nozzles from the nozzle load and define the clearance of the cut and make the equal clearance here by selecting this button. So the whole of the cut will be greater than the outside diameter of the nozzle with 2 millimeters. And from here, let's create the cut, and you will figure that SEG will create a cut on the elements automatically. Here, the first shell course, SEG detect the nozzle and create a cut for this nozzle, and for the second nozzle at the bottom. On the second shell, SEG detect the nozzles and will create the nozzle cut. Okay, for each nozzle. So SEG will help you to make that automatically. If you would like to get sheet metal development or shell development for this part, you can get it easily by using this tool to generate the nozzle hauling on the shell plates. If you would like to get the shell development, and I will show you how you can make that. There is a tool on SEG software to detect all sheet plates on your project and get the sheet metal development for it. And if you would like to select a defined element like a shell blade to get a shell development for it, you can do that easily. Here, after finishing the shell development, let's collapse all childs and save the assembly. If you open this shell blade, for example, you can figure that you have a cut for nozzles. So if you would like to get shell development, you can get it directly like that. Okay, and you can figure that the welding line, that welding line on 55 degrees, I think, or 305 degrees. Okay, so let's come back to SEG and close this window, and let's close this part. If you open this shell course, and if you would like to get the sheet metal development, you will get it like that, and the welding line here on 55 degrees. Okay, now let's create a vortex breaker on this shell. So let's select CAD 3, and from elements select and group of internal attachments. If you take a look to the elements here, you can add impingement baffle deflector, bundle retainer, but we need to add a vortex breaker. So from here, let's add vortex breaker for N4. So you will find different types of vortex breakers, like that. Okay, and in our case, let's select the type 2. Okay, that type. Okay, and let's define the size of the nozzle, which is nozzle suits the nozzle N4. It's 6 inches nozzle with schedule 80. Okay, and the thickness of the blade will be 10 millimeters. The location will be the same location of the nozzle, 1330. The orientation 190 degrees. The material of this one. So if you would like to make it user defined, you can change the value from here. So the depth, which is dimension, we can define it from here. If you would like to add a circular plate or add a perpendicular plate, and define the material and click on save. Now if you click start the assembly, here's that's the vortex breaker. Okay. So let's take a section here. Okay, that's the vortex breaker here, like that. Okay, but if you take a look to the drawing here, you can figure that this vortex breaker from three fins only, not 4. So the 3 fins, it's not included type in SEG, and you can create it manually and import it to the 3D model if you would like to make something like that. And as mentioned in our tutorial videos, we offering creating any special item for free. So if you would like to inform us about the required items, if you would like to add a special spec or a special part, our technical team can do it and include it in SEG library. Now let's add the stud bolts for the body flanges and add manhole davit and the other attachments. Okay, now let's come back to SEG, and from here for the manhole we have a cover here. So on this cover we would like to add a stud bolt. So if we open the Trouvé catalog and take a look to the size 24 inches nozzle. We could use for the raised face nozzle a bolt with 1¼ UNC and with a length 175. So let's add stud bolts. Image stud. Let's select UNC and from here 1.25 and for the materials of that's the material of the bolt. Okay, and the material of 2M. Okay, the total length will be like that, and the knot spacing, which is the spacing between the two knots, so we will need to measure the distance from here to there. Take that value, so copy, and click on save. Now we will create a stud on the on this cover flange. Here we have the stud bolts for this connection. And if you would like to add a hand grip, so from elements, let's add hand grip, image grip. Okay, you have different types of grips. You can select the suitable type. We can select this one, keep those values as they are, and defined we have 2 hand grips. And finally, let's add davit. We have two types of the man-way davits. The first type as a one part, so no details inside this part. So if you would like to include it on the 3D model as a one part, you can use man-way davit. So MH davit. Okay, and from here you can select the suitable type for your case. Okay, so in our case we could select that type, which is type C, define the pipe outside diameter and the orientation. Let's make it on 90 degree right now and click simply. Okay, those are the hand grips. And here the top davit, sorry, that's the top davit. You can change the orientation of this one. So let's change the orientation and make it at 0 degree. Click on start. Okay, so here we have this top davit, and if you would like to include a detailed manhole davit, let's select the blind flange, and from here let's add detailed davit. Okay, and from here you can figure that you have the ability to select from some standards listed here, like that standard. For example, you can select the type for of the manhole, so you can select the type and define the dimensions of the manhole, and in this case you will get all items of this manhole listed on the bill of material. Okay, so you have a list for each item of this manhole davit on the bill of material. Okay, so let's delete this one, and let's add another stud bolts to the other flanges. We have N7. Okay, so let's select N7 here. It's 2 inches. So N7 stud. Okay, so if we open the Trouvé, so 2 inches, we have 5 divided by 8, and the length is 85, so 85, and the material here is 2HM, okay, for the knots, and 4 bolts P7M, okay. And let's measure the knot spacing. So from here, you will need to measure the knot spacing, okay, and take this value as a copy and click on save. Now we have another nozzle, which is nozzle this one, which is nozzle N10. Okay, so N10, if we come back here to the list, N10 is 6 inches. So if we open the Trouvé, the 6 inches is 3 by 4 with 100 millimeters length. So let's add N10 stud, and 3 by 4, the material of, sorry, here that's the material of the bolt, the material of knot, the first knot and the second knot with the length, and from here we can measure the spacing. Let's copy this value, put it here, and click on save. Now for nozzle N11 cover, let's add 11 stud. It's 2 inches with the rating is 300, so let's open the Trouvé. So it's 2 inches with 300, so 5 by 8 with 90 millimeters, so 5 by 8, okay, and it's 90, the material of the nut, and here's the material of the bolt, and the knot spacing. Let's measure it from here to there, copy this value and paste it here, click on save, and let's close this form. One more option we could make it here, which is on the setting, which is auto zooming. Here if you select normal, so no zoom extend will take place after modification, so the view will be the same. Here if you click on start as simply and take a look here, so the view will not change after importing this item. On the default option, after importing any item, Autodesk Inventor will make zoom extend, but in this case it will keep the view as it is. So now I will move the view to the second nozzle. Okay, now we create the stud bolts for all the model. Now we need to make a cut on the width of the stiffening ring, and now we will learn how to make that. Okay, now let's go to the level of the part from the assembly model. From here, let's go to the level of the this stiffening rib, and from here let's create a sketch. Okay, by after double clicking on this one, let's create a sketch here and project the wear plate of the saddle here, and the outside lines of the saddle. Now after finishing, we can open this part separately after creating those lines, and let's change the properties of this one and make color as blue to be able to see it, and let's make it like that. Now we have this cut on the saddle. If you get the arc option and create an arc from here to there, the same from here to a certain point here. Let's make a construction line to help us to make a mirror. Okay, so let's select this one, that one, and that one, and let's make a mirror around this line. Okay, so from here we can make line like that, make that one as a construction line. So now we have the end point of this one. If you would like to increase the cut from here to there, you can do that, but right now we will make it the same. So if we make a cut here, make a cut on the two sides, click OK. Now we make a cut on the web by that way. So here you can figure that we make a cut here, and we need to make one more cut on the outside ring of this outer stiffening ring, but the rib itself we get this cut. And if you would like to make a modification like make a notch or something like that, you can do it easily on the sketch itself. For example, if you would like to increase this cut a little bit, so you can increase the arc length from here to there, okay, and add another closed area, and you can make a cut for it. Now let's make a cut on the outside ring. So let's select the outside ring, and from the sketch let's select the plane XY plane, and let's project the outside lines from here to there, and let's click finish, and let's open this part separately. So from here let's open the second part, go to this sketch, let's change the color from yellow to blue, and from here let's close this area. Now we have this closed area, so we can make an extrude cut all through all, and let's click save. Now if you take a look to the 3D model here, you will get a cut for the stiffening ring on the saddle by that way. Okay, Alhamdulillah, we finish the 3D model of this equipment. One more thing we will need to do, which is the internal support for this nozzle, and we will discuss on the next tutorial, inshallah, how to make those and how to prepare for our drawings, how to make our own title block and border, and how to import those views to the drawing, including the bill of material and the other tables. Before finishing this session, I would like to give a hint about the tables here. If you open the bill of material table, you will find a complete and a detailed bill of material for your equipment. Here, that's a list of items. You have 65 different items. The total number of items is 211. Here I have a description for each item and the technical characteristics for each item and the material for each item, the weight and the total weight for the equipment. Okay, so you will get this detailed bill of material for your equipment. You can export it in Excel format. So from here, for example, if you would like to export it, let's select the desktop and create the BOM of today. Let's like that. Now if we close this one and go back to the desktop, sorry, here if you, that's the exported bill of material. If you open it, you will get a detailed bill of material, and you can figure that you have a part number, the part name list to indicate you where this item referred, the reference of this item. You have ellipsoidal head, it's for the right head and left head. For example, for this flange here, you have 4 flanges with the same description and the technical characteristics. Here, if you take a look, it's for N9 flange, N2 flange, N2 flange 2, and N2 flange. So you have those 4 identical flanges for the same item. SEG make the listing depends on the identical items. They should have the same description, same technical characteristics, same material, and the same weight. So SEG will detect that they are identical items and will sum them and give them the same item number. Okay. Now let's take a look to another table, which is the nozzle table. Here you will find a list for nozzles in our model. Here the nozzle tag, the nozzle service as defined, the nozzle outside diameter, the nozzle orientation, nozzle thickness, nozzle scalable. Okay, the nozzle flange class, so that's the rating of the flange. The type of the flange, it's a weld neck or long weld neck. The facing, if it's RTJ or rest face or flat face. If you have a blind, you will find here on that table the blind class and blind facing, the internal projection and external projection, the bad thickness, rebad width, and the weld style for the nozzles. Okay, here another table for the material list. Here you will get a list for the head material. So that's the material of the head. And the seamless pipe, that's the material of the seamless pipe and shell, support plates, and lifting lugs material, nozzle neck material, and flange cover, gasket material, nut material, and hand grip material. So different, the list of different materials you can get it from here. Another table for nozzle orientation. So here that's the table of nozzle orientation. Okay, I hope that session covers some important points regarding 3D modeling. And as you can see, in maybe 1.5 hours, we create the 3D model for this equipment, including a detailed description for each item. And inshallah, during the next tutorial video, we will discuss how to create the general arrangement drawing and the detailed drawings for this equipment. Thank you so much for your valuable time. And if you have any questions, kindly write it in a comment. And you can contact us in contact at secadsolutions.com or secad solutions@gmail.com. Thank you so much. Have a nice day. Assalamu alaikum wa rahmatullah.